Okay, so let's find out how to set up F equals ma equations with centripetal force. But before that, um, let's review directions. So this is r hat, the r hat unit vector because it only has one as a magnitude of one. So a vector like this can be, well, it's of course equals to F equals ma r hat direction, and I can represent that vector as minus 4r hat, minus because it's going the other way. So that's why the equation v squared over r in this definition of uh, the unit vector, it's going to be negative v squared over r. So let's go do some problems, and let's do the vertical circle problem, and it's got problem solving steps also. Alright, first draw a figure for the problem. Next, you want to state what you want to find and what's given. So I'd like to um, find omega, minimum omega, such that trajectory remains circular at top, more like when mass is at the top and given r and gravity. Okay, next I'm going to show the axes, rotating frame axes, which is just the r hat, right? And next we look at the force diagrams. So it's tension and gravity. Oops, mass times gravity. And from that force diagram, we can make the F equals ma equations. So F net equals ma, the r hat direction, is equal to minus tension, right? It's pointing to the center, minus mg, and we've defined r hat to be pointing away from the center. That's why we have the negatives. So that's why r hat is equal to negative v squared over r. Reason for that is negative r hat direction. The acceleration is in the negative r hat direction. So we can rewrite this as minus mv squared over r equals minus t minus mg. And we want the minimum velocity so that it makes a circular trajectory. So any greater than the minimum velocity, then tension will pull down, right? And any less than that minimum velocity, then you get a lopsided circle. So, well, down here, and then lopsided there at the top. So I propose T has to be 0. Tension has to be 0. That's when tension is 0, that's the minimum velocity to achieve a circular trajectory at the top. Alright, so I can rewrite this as mv squared over r equals mg. And m's cancel out. Oh, and we need to list the knowns and unknowns. Make sure that we can solve the equations, yes. Known as v. And got v equals square root of rg. We wanted omega, right? So omega is just, well, r is equal to, no, v is equal to r omega. So we got omega is equal to 1 over r. square root of RG. Alright. Let's look at another example. Banked highway curve, design speed. Driving on the highway and some parts are slanted, so why? So here we want to find V given, we are given the radius of the curve, coefficient of static friction, and we got theta. Axes directions. Alright, looking at it from the side, you got x hat direction, the y hat direction, and going up is the z hat direction. So this is, looking at this would be like the x hat. Get this figure right here. This is the y hat, and going out of the page would be z hat. Okay? And so this would be like z hat. And then we got the rotating frame, right? You get the y hat and the x hat. This would be the r hat. It's going to be going around, right? So, like looking at this picture, it would be, this would be r hat. Force diagrams, right? The free body diagrams. Here's your car on the incline, so you got normal force on the incline, you got gravity, and you got perpendicular to the normal force is the friction. And this is a vertical, this is a horizontal, this is theta right there, theta right here, theta. Okay, so let's look at the z hat direction. Forces in the z hat direction be n cosine theta. And we got gravity and a little bit of that friction. F sine theta. Okay, now we look at the r hat direction. So looking at this one, this would be the r hat direction, and this would be the z hat direction. Z hat direction. Based on this diagram. So this would be n sine theta. Oops. This would be f sine theta. Oh no. So n sine theta, that's what I got, and this one is f cosine theta. Right? F cosine theta and f sine theta. Then this is the r hat direction. Sorry, this is the negative r hat direction right there. It's the other. So hopefully you see the directions here. F equals ma equations. We got in z hat, we have f net equals ma z hat n cosine theta minus mg. Looking at this one, mg f sine theta. Alright, this is actually 0 because not moving up or down. This one's not moving up or down, so 0. And in r hat direction, f net equals ma r hat equals minus f cosine theta. Looking at this diagram, minus n sine theta. So AR, this one is actually minus v squared over ry, negative r hat direction. That's the reason for that. So we can simplify this. Zero equals, and we can simplify this. So that's minus mv squared over r. Coolio. So we got knowns, say m, g, r, g, r, and theta. Let's assume that we know n, but just like the last problem, m actually cancels out. Spoiler alert, I guess. Don't know those. So we got 3 unknowns, but only 2 equations. So this step, you figure out that you missed an equation, which is this one, the friction equation. So now that we have 3 unknowns and 3 equations, we can solve for the unknowns. So let's start with the first problem, first equation. Substitute f. So I'm going to be substituting and factoring at the same time. Cosine theta, sine theta minus mg. Then I can rearrange, solve for n, g cosine theta minus mu sine theta. Right, and can do the second equation and plug in for n and friction. Right, so mv squared over r. I'm going to be substituting and factoring at the same time. Us cosine theta plus sine theta. And this is the factored out n, so this is just writing down n. Alright, so this is just n. So solving for v, we got rg divided by theta minus u sine theta. Alright, so that's how you handle centripetal force when doing F equals ma. Alright, hope that helps.